Thank you. I'm Chinmayee, currently working as a postdoc researcher in the Department of Physics, Informatics, and Mathematics in University of Modena. I did my PhD in the Indian Institute of Technology, Kharagpur, as the chair introduced. So my work is on magnetic two-dimensional chromium telluride metamaterials for harvesting acoustic waves. So the contents of my presentation has an introduction to the acoustic waves and the usage of tellurides, its synthesis, its structural characterization, the magnetic behavioral of both bulk and 2D, the theoretical studies, device fabrication and testing, and the mechanism that holds. We observe acoustic energy on a day-to-day basis, and currently the nano limit of acoustic vibrations observed in instruments are Helmholtz resonators and cantilever, piezo cantilever beams. And these have a perfect periodicity of acoustic materials that are usually disrupted by energy bands when the magnets are exposed. And these things are also observed in the nano generators that we use these days for energy generation. There are multiple materials that have been tested as nanogenerators since 2012, and some of it are also tellurides recently being exposed. So my work has been on tellurides consistently for the past few years, and one such telluride which was explored here was chromium telluride, CrTe3 composition, and when incorporated as a nanogenerator, how it operates on the diaphragm of a loudspeaker. That was tested in the study. So the bulk chromium telluride was synthesized by induction melting, and we confirm its phase formation using SEM, EDS, and XRD. It has a monoclinic structure with van der Waals bond in between layers, and it was easier to exfoliate them. We did exfoliation in a liquid medium IPA, and we were able to obtain overlap thin layers. These layers are not exactly as what you get during your chemical vapor deposition, but they fall in two-dimensional limit, and we can use these thin structures for device fabrication. And once these liquid are rested for more than 24 hours, we collect the centrifuge supernatant on top of the solution, and we use these material for device fabrication. And then analyzing further on the morphological aspect of the material, we were able to see that the lateral dimension of each of these flakes are quite wide, and the thickness is about 4 to 6 nanometers. And we did other spectroscopic studies as well to confirm its chemical composition, even when it is liquid phase exfoliated. So as for the magnetic behavioral studies, in bulk, we do not observe any hysteresis. And when we move to the 2D dimension, at room temperature, we see that it has a ferromagnetic nature, and we test this with the different temperatures as well. And as compared to the existing 2D chromium compounds, which have a Curie temperature around 150 to 200, so our material had a little higher Curie temperature. So the transition depends on the based on how the synthesis method was used. So the theoretical studies showed us that we were able to retain the long range ferromagnetic ordering even in the 2D limit for quite some time. And we observed that there was a band gap opening in the structure also, which is usually observed in all 2D materials. And this helps us retain charge when used in the nanogenerator. So for the device, we were able to incorporate these flakes in thin polymer matrix, which were magnetically responsive, and when applied load on these devices, we were able to see that it has a highest sensitivity with very least load, and these devices were also capable of sensing mechanical strains, and which had a quite high power density for very low frequency application. And as I said, when we were able to install it on the diaphragm of a loudspeaker, there are inbuilt permanent magnets of 1.5 uh, millitesla on these um, devices, and these influence your charge movement in on changing frequency of the material. And basically we calculated the other electrical measurements, capacitance and frequency. And the device was also uh, capable of harvesting energy with change in temperature as well. So the mechanism of what is happening inside these particles is on application of external magnetic fields, we see that the charges in the tellurides are being disrupted, and until some exposure of magnetic field, we are able to see a stable charge distribution when measured with zeta potential. And we also did EIS measurements, and we were able to see that the charge transfer resistance on exposure to magnetic fields uh, actually reduces the charge transfer resistance in the material. And the magnets inside these loudspeakers actually polarizes the randomly oriented spins in the particle, making it ordered ferromagnetic structure. And this actually eases the charge flow and increases voltages in our study. So to summarize, the application of these 2D tellurides is we are finding new materials for application in the device range. So all these devices are influenced by external magnetic fields. And if we can use these external magnetic field for um, an advantage or increasing in our performance of the device, so we can use these ferromagnets with higher Curie temperature, and we can harvest acoustic waves which are produced, and the devices are able to obtain a very high surface charge density of 2.9 millicoulomb per meter square for a very small device. And we can tap into the magneto-acoustic vibrations that are usually produced by these frequency changes in the vibrating device. Thank you.
Thank you very much for your presentation. So now this paper is open for discussion. Do you have any questions or comments? Can I ask you a short question?
Yes, please.
So your material has a few layers, right? So
Yes.
is there any dependence on the number of layers of the
Yes, it
material?
actually depends. The magnetic field varies with the changing layer thickness, but in this particular study, I have just compared the bulk with 2D. But to continue the studies, we are actually exploring different layer thick flakes in MFM. And we are trying to study how it varies. So after a particular number of layers, it starts behaving as bulk again. So until 3 to 4 layers, it is okay. And after that, the behavior is almost as the bulk.
Okay, thank you.
Thank you.
Is there any other comments or questions? any other questions or comments? If not, I would like to move on